Hello everybody, my name is Ryan Stolys and this is my Math CCT. Today the question we will be doing is identify the key characteristics of y equals -2 cos bracket 4x plus pi bracket plus 4, and then we will check with the graphing calculator. So our first step in order to answering this question is first we have to look at our base function. Our original function, in order to identify the key characteristics of this graph, we have to know what each of these numbers does to the graph. And so what we'll do is we'll break it down into the base equation, which is y is equal to -a cos b x minus h plus k. So as you can see, this bottom equation, the correct equation, does not match the top equation. The b variable is inside the brackets in our original function, whereas it's outside in the correct form. So what we have to do is we have to move it outside the brackets so that our original function is in the correct form, and then we can see how each number affects the graph. Alright, so now we have our equation into the correct format, and so what we can do is we can graph our original function and then start applying transformations in order to determine how it impacts the graph. Let's try it out. And so the first thing we're going to do is we're going to graph our original function, which is y equals negative cos x. So we'll plot those points and graph it in. We have our original cos x function, negative cos x function, and what we'll do is we'll apply our first transformation, which is the a value. The a value is 2. So we'll apply that and we'll see how it impacts the graph. There we go. We have our y is equal to negative cos x in blue, and we can see that it's stretched by a factor of 2. So our point here at -1 went down to -2. Our 0 multiplied by 2 doesn't do anything, so it stays at 0, and it moved up to 1. So we see that it's just a lot more stretched, but it's still the same period. It's just the same. So that's what our a value does. Our a value deals with the vertical stretch and compression of our graph. Next, we'll deal with our 4. So what we'll do is, so here we have our now adjusted graph of y is equal to -2 cos x. You can see that it's been stretched. So now we're going to adjust it, or transform it, so that we input the b value. The b value deals with horizontal stretch and compressions. So we can see here that it's 4. That means it will compress the graph by a factor of 4. So what will that make the period? So we have a 2 pi period, that's going to be compressed by a factor of 4. And so in order to figure out what the new period will be, we can plug it into a simple equation that will tell us. So I'm going to write down that equation and we'll try it out. So here's our equation here. Our equation is the period is equal to 2 pi over our b value. So in our situation, our b value is 4. So we can input the 4 in the b value and see what we get. So our period is equal to 2 pi over 4, which can also be written as pi over 2. So this is our new period. So this graph, which is currently 2 pi as the period, one cycle happens in 2 pi, it will be compressed so that one cycle will happen in pi over 2 degrees. So we'll add a couple more ticks on the graph and draw in our new graph with a period of pi over 2. So now we can see that our b value of 4 compressed this graph quite substantially. And so since that's happened, we have one cycle occurring in pi over 2. So it goes up and back down, and pi over 2 is one cycle. So now what we see with the b value, it's compressed the graph by a factor of 4. We can move on to our next translation. This is a translation of pi over 4 units to the left. Since it's the plus moves it to the left. And so we'll try that out. So here we are. we've drawn our y is equal to negative 2 cos 4x graph. Drawn a little bit neater. You can see how it works, how the graph's compressed. So now we're going to add a translation. So y is equal to negative 2 cos 4 bracket x plus pi over 4. So what we can see here is I've drawn this in. This little tick here is pi over 4. So half a cycle occurs in pi over 4 units. For example, this point's going to move basically 2 ticks is how you can look at it, because you have 1 to here and then 2 ticks is pi over 4 units. So this point will be 1, 2 units, and this point 1, 2 units. And so that's what we'll do, is we'll shift the graph over pi over 4 units, graph it, and see how it looks. So there we have it. We have our graph, which is pi over 4, shifted pi over 4 units this way. And so this point here has been shifted and everything's been moved over. What I've also done is that this point here was shifted 1 pi over 4 units to there, but that would mean that our graph would have ended there. So what we did is we added a couple more points so that we could get up to our full domain of pi over 2. And so now that we have this graph here, we can add our final translation, which is our plus 4. And we'll see how it goes. And so the final step in graphing our original function is to add our negative 4. So the blue graph here is y is equal to negative 2 cos 4 x plus pi over 4. So now we have to add our final translation, which is 4 units up. So this value here shifts the graph vertically up or down. And so since it's a plus, we will shift it 4 units up. If it was minus, it would have gone down. And so when we shift it all up, we'll see it'll be in full view up here, and so the bottom of the graph will be here, the top up here, and we'll see what the final function looks like. There we are. We have our final function of y is equal to negative 2 cos 4 x plus pi over 4 plus 4 graphed onto our graph. Now we will begin the online check of our work. So first we will start with the y equals negative cos graph. As you can see, this graph begins at negative 1 at 0, is at positive 1 at pi, and is at negative 1 again at 2 pi. Now we will add our first translation of the 2. So as you can see, it was stretched by a factor of 2. It is at negative 2 at 0. The 0 remains the same. The x-intercept remains the same. It is stretched up to 2 at pi, and then remains and goes back down to negative 2 at 2 pi. Following that, we added our period, and so as you can see, it gets compressed extremely. So by a factor of 4, the graph is compressed very much. So you can see that a full cycle occurs in pi over 2 degrees, pi over 2 radians, which is also 90 degrees. And you can also see how many cycles you get in the in the 2 pi domain. Following this, we added our translation of pi over 4. So as you can see, the points were shifted pi over 4 radians to the left. And so the blue graph is the adjusted one. So, then we can see that. And now we can add our final translation, which is the vertical translation of 4 units. Just move up the graph so you can actually see. As you can see, the top and bottom of the graph are between +2 and +6, which is what we had on our drawn-in graph, and the graph is correct. So thank you for watching our lesson, and I appreciate you listening.